Hello everyone, my name is Preetham Deshpande and I'm the program manager working with geometry and meshing team. Today I will be talking about the CAD and geometry updates and followed by Salim who would talk more on bit meshing functionalities. Yashwant will take over from him, continuing with the meshing updates, and finally we will have Tim talk about the morphing updates. So for this version for CAD interfaces, we have a new reader updates, Creo 9.0, CATIA 3D Experience 2022, NX 2206, which is the native NX, and Inspire 2022.2. Uh, Based on the amount of versions that we support, we will be removing the NX 1953 native support. From the CAD interfaces, we have added capabilities of updating the parameters from Inspire files. So let me talk about it more. So we in the past have supported parameter updates for UG. Back in 2021, we also did for CATIA, and in this version, we are supporting the Inspire parameters as well. So whenever you will read file from Inspire, as long as under the preferences you have the Inspire installation directory specified, we can read in the parameters, and through the entity editor you can update the values, which will basically run Inspire in the background in a batch mode, do the updates and send back the updated geometry. You can also uncheck this option, which will not show the updates immediately when you change it in the entity editor, because if users are interested in doing multiple updates, then you can change it at once by changing all the values and then going through the CAD update tool. One more point I forgot to mention is that if you have done any geometry editing, basically the that geometry editing does not count, in a sense that since we always send the original geometry back to Inspire that was read, the updates will be done to the original geometry when you bring it back. So before doing any of the geometry editing in HyperWorks, you should do the updates that are required on the parameters, and then start editing your geometry. Now coming back to geometry updates, we have added a few new workflows, surface repair tool, surface creation tools, which were migrated from the panel like skin and from FE. There were other tools that are surface creation tools also that we put in under ruled surface, and I will talk more about it in detail as we go along. The other new tools that we added under sketch are the pattern tool that are coming from the new sketching library. And we also have enhanced the current workflows, adding the non-uniform distances for drag as well as line offset. So I'll go more in detail on the capabilities as we go further. So on the cleanup side, we added surface repair tool. This is a very useful tool when you import a geometry and you want to look at certain common problems. As you can see here under the options, we have under validate all of the things that we identify and fix. You can also change all the tolerances, and once you set all of your options correctly for identifying the free edges, non-manifold, self intersections, sliver surfaces, and so on, it'll identify all the problems. You can click on whatever are the fixable, it'll try to fix it, and then the remaining ones you can go in each tool with the model tool options provided here, So there are delete surfaces, there are patch surfaces, there are stitch and stitch intersect, which are again more common. You can go through your model and fix these areas and get a closed shell, which is basically right before creation of the um solids. So once they are ready, you can create solid out of it and complete the workflow. You can click on legend to go to each of the errors. Now, I also would like to point out that whenever you are fixing these issues, sometimes you will see other issues popping up because fixing of one things help HyperWorks identify the other potential issues. So don't get um, I mean, it's not an error where previously it was not showing any free edges, but then afterwards it does show some free edges. But you can always automatically go and try to fix it. And there are other tools that are that will help you, kind of walk through the model. So it's again a very useful tool. I would recommend you use it and give us a feedback. There are a lot of visualization options that we have added, and I'll talk over more in detail. So I just wanted to kind of go over the surface repair tool, which is a big addition for this particular version. So it's added under cleanup, and once you click on it, you will get these options under validate, which basically you can expand on. So these are all the checks that it does, along with the options that you can define to fix these problems. So I can, for example, for free edges, there are different options that I can choose as automatic fixing with the tolerance value. And certainly there are other options like self intersections, slivers. I can also define and update these values. So based on all these options, you can either select only few, or you can click on find, that it will do all of the displayed surfaces it will take into account and try to identify all the issues. We create this legend pertaining to each of these issues, and once this legend is created, you can click on individual errors if you would like to handle few things. If not, at first, we always recommend that based on the options you um, click on the play button, which will basically go through the model and try to clear out some of the errors automatically. Now, I would also suggest that because these are all interlinked, sometimes you will see that, for example, there were no self intersections before, but now it has self intersections and no free edges, right? So that is possible based on how it handles the errors, and we can also work on it a bit, but it is possible that it exposes some other errors in the model as you're fixing it. So in this particular case, if I click on duplicates, it takes me to this particular secondary tool. I can either go through model tool, or I can just, since there are only two, I can quickly handle this. Again, this duplicate surface, one of the surface would be removed. And as you can notice now that there are no self intersections, right? It has also fixed some of the self intersections, but now it is also highlighted with the lot of the free edges now that it has identified. We are also working on some of the graphics things which are not supported yet on actually coloring these as per the errors. So that will be coming in the next version. But I can again go back and check these things to see if I can automatically fix them. And now it has reduced the free edges from 35 to 3. I can go back here and go into the model tool. Um, each of these tools also has relevant options under the micro dialog. So whatever option that I showed you under the validate options, those will appear. For example, here, if you want to delete the surface, if you want to patch, the surface, or if you want to move between stitch and intersect, which provides more value to the user. So in this case, let me patch this particular surface. And since I was in the model tour mode, it is taking me to model tour. I can always exit. Also, I want to highlight that we have added certain options like selecting adjacent surfaces. So you can select adjacent surfaces, save it for later, and escape it to visualize it, the problem areas if you want to, if for a certain complex things. So once I do that, now it tells me that there is a close bounding surfaces available. I click on that and it creates a solid out of these surfaces. Some of the panel functionalities of creation of the surfaces itself, we have transferred it uh, to be added into the new surface create option like skin and from FE. As you can see from the videos, we can give a list of lines to create skin surfaces. On the right, if you have just an orphan mesh, you can create CAD from it. So we have supporting from FE where you can select all your orphan mesh, select the features if you have created, and you can create the CAD surface out of it. Since now we are also supporting FE geometry, if user selects any FE geometry whilst in this panel from FE, then it will give a user a warning whether he wants to destroy the FE geometry and create CAD. So user can then pick whether he needs a CAD surface or he's okay with the FE geometry. So that option is newly introduced in from the panels here. This is another enhancement from the field that we always hear, that there are different methods in the current panels where you can mix and match between the nodes and lines or nodes and actual um, free nodes or FE nodes. So here are different options to create surfaces based on location to nodes or locations to locations. So we can create under ruled linear. These options are all supported. I also would like to point out here that we are trying to um, provide create mesh option here that is still in the works. I'm not sure if we will make it um, for this release, but I would like to still mention it that we are working on this option that was previously supported under 2D page for all of these ruled and drag, where user could create a surface with a mesh. Under the drag tool from the panel, we had a few options to create a non-uniform drag. So for example, it creates micro dialogues at each of these ends, and you can give different values to create a surface drag from a line. So that this new option is now supported in this version. On the similar lines, we do the same thing for the offset tool of lines. Since we added the line offset tool, we kind of separated previously the offset tool was under the surfaces, but now offset tool is in it on its own, that we have moved to a actual ribbon, and all the surface and solid offset have been moved under this offset along with the line offset. So here, as the video shows, you can there are different options from the panel that are supported of non-uniform offset, deleting the original line or reversing the direction of the offset, and so on. So again, all of these options from the panels are now transferred under this tool. We have also migrated our edge filleting, which is the defeaturing of the edge fillets from the panel. As you can see, to maintain the consistency between the uh, 3D fillets or surface fillets. We have provided a similar technology here where we can go through finding of the edge fillets based on certain radius range. You can also go through a model tour. You can individually remove them. You can remove in bulk. And you can also visualize. It also gives you a nice visualization of the where the fillet starts and where it ends, so that user has a clear idea of what he or she is going to remove. We also updated our sketch libraries, and part of the update gives us this new tool called pattern. We can add circular patterns, so you can define, select a pattern that you want to create, and provide angle and number of instances to create a circular pattern. Here we are showing the linear pattern where you're giving the direction and spacing between each of the instances and how many instances you want to create. So you can create uh, these patterns very easily. Other improvements in the sketching is done at the grid spacing level. We started supporting units in the previous version, and based on the units now, we have adjusted the grid spacing. Previously, whenever you start with a small sketch, it would be really small, the grid spacing, and we have to zoom out to create a realistic model. So now, based on the grid spacing, you don't really have to zoom out and create these models. You can right away start sketching very neatly. Also, if you have a certain model already loaded, so based on those dimensions, it will adjust the grid spacing as well. We also support duplication of the variables along with the duplication of the sketch. So previously, when you used to duplicate sketch, if there are any variables which are attached to that sketch, we were not duplicating it. Now we are supporting the duplication of those variables as well as parameters. Now I will hand over to Salim.
Thank you, Pritam. My name is Salim. Hi, everyone. So I'll be talking about meshing updates with respect to 2022.2. So we have updates with respect to mid-mesh, where we have a fillet treatment factor. This we enhance to improve the mesh quality, which is coming from mid-mesh output. Basically, if we want to treat a fillet in a particular way, then we use this factor. Then we have hex tool, which helps us for solid meshing. Then we have edit element. We can create an 3D element using edit element now. Then we have mid mesh imprint, which basically I can upfront modify my imprint preview using my handles. I can move handle, add or remove the handles, and get the imprint done. Then we have smooth, where we enhance the algorithms in such a way that it gives us the better output now. So let me dive into mid meshing in detail. As I said, we have mid mesh filler treatment factor. Now, if you want to capture a fillet in a particular way, I can define by a separate factor, which was previously with the general proximity edge factor, which in a way had a larger value. So we had certain inconsistencies in the mid mesh output. It used to suppress at some point, and it used to capture at some point, so which caused a dent, and we had to manually correct the mesh at those locations, which in a way it used to take us a lot of time in mesh editing. So this gives the consistent mid mesh output on the fillet. If the fillet is of the lesser width than the factor times the mean size, then what we do is a midline trimming, which was never happening previously, which was like always the proximity. One of the edge was getting suppressed, the other one was not. So now we try to do a midline trimming. If because of the complexity, even the midline trimming doesn't happen, we consistently suppress one of the edge so that the mid mesh output looks better, and we can save a lot of manual editing time on that. So this is mid mesh fillet, and then what we have is the improvements. What you see here. The improvements is like the consistency in the fillet capturing. Then we have continuity. There's no collapsing as such because the factor is now different than the general proximity edge factor. Then since I can give the value lower this factor, and then rebuild will take it to clear the quality at that locations. Apart from that, in the mid mesh output, now we have removed the unwanted edges that is coming. Basically, those doesn't has any deviation, and this comes from the ribs which is having fillet at the edges, and those fillet edges were getting imprinted. So we wanted to specifically treat these fillet which are coming from the rib, which we didn't want to capture them. So we remove it on the extraction itself. Which previously used to take us a lot of time for identifying those and suppressing them manually. So this gives us a better output, and after rebuild so these nodes does not get constrained, and so hence we get the good output as well from the rebuild. So let me go to a demo on this. So here is what I was talking. So here I have a fillet which is basically captured now. So this fillet is having a width of 2.7, and on the other end, say it is having 2.83, right? So now this is captured. Let me just delete this for now. Now I want to midline trim that. So now the factor by default it will be zero point 0.6. Now I'm just changing it to 1 so that anything lesser than 3 it'll do a midline trimming. So if I do a mid mesh extraction, so what it will try to do is it will try to midline trim like how we see it, right? So it will not push the nodes out of the geometry, and it will try the consistent fillet capturing on the midline. So this gives us the better mid mesh output, so that the manual editing time goes down, and also if I am doing a rebuild on this, I'll get a good output. So I can just show some of these examples where it really helps. Uh, so if I am going to one of this view, so yeah. So if we see here, so the fillet is captured. This is in dot two, and this was in dot one. So there was some inconsistency in the fillet capturing. I see a lot of dents, which later on I had to align it, which used to take a lot of time. So now upfront we have good output. I know even if I'm doing rebuild on this output, it would give us a good mesh there. So a lot of editing time where we used to imprint certain edges and then align it, or split and then align it, has reduced a lot. So if I'm going to the other weave, now we see this fillet has defeatured, right? So because it was not able to identify certain edges as the fillets and treat them differently, so it was defeatured. Now we identify those as fillets and imprint them and then capture it in a better way, right? So even if there is this, the width is failing for mean size, I can do node movements on the rebuild and get the mesh better there. I can clear the qualities as well. So if I'm doing for this, I see a lot of dents here, right? It's in dot two. So this was the fillet, and later on I had to align this. Now if we see here, the mesh is well aligned, so we don't really have to correct it later on. So this was also I spoke about unwanted edges, correct? So what we used to happen is these edges on the fillets were getting imprinted. Basically, those didn't had any deviations, but still used to get captured, and sometimes it becomes really manual work to identify them and clean them. So now we don't have any edges that is getting imprinted at this location. So these kind of edges are avoided. So these edges Now we don't see those edges. So the mid mesh output has a better result now, even with this, if I'm speaking. So this was inconsistently captured as one of the edge, and we had this dense. So if I am capturing it with the lower factor now, so I'll be able to, so if you see, if I am capturing it with the factor fillet treatment factor, I can get the mesh better in the midline. So even if I see, this will be in the midline, and but this will be suppressed as proximity, which is not even consistent. So here I have one more seeding that needs to be removed. Also, it's not midline trim, which was having a lot of dent and needs to be aligned later on. So this is about the fillet treatment factors. And then we also have, let me come back to the presentation. We also have imprint enhancements, where if I'm imprinting, sometimes it used to not give us the desired output because snapping was done internally, and sometimes user like the snapping, sometimes he doesn't. So now upfront we can correct if something is not coming as per the expectation. We can move the handles. So if the handles are not sufficient, I can add it. If it is more overlapping and all, we can remove it. So this is about imprint. Let me just quickly have a demo on imprint as well. So this is mid mesh on line. When we have the source as line, I can just imprint them, right? So now I see these are getting overlapped, and afterwards I might need to clean the overlapping lines as well. So now upfront I can remove certain handles, or I can just move certain handles, snap it, or I can just remove them. And then if certain handles needs to be added, I can left mouse button, I can add it, or we can also move them. So imprint will adjust accordingly. So this gives us a benefit, like we don't have to do again editing, such as removing of the handles or sliver elements, or replacing of nodes. Upfront I can correct the handles and get the imprint output as per the expectations. uh, yeah, so thank you very much. This is all from my side. I'll hand over to Yashwant now to take it further on the edit elements and solid meshing.
Thank you, Salim. Hi, everyone. I'm Yashwant Patil, and today I'm going to talk about edit element enhancements, general meshing enhancements, and the capability we added for the solid meshing. So, the first one is related to edit element create tool. Earlier, we were able to create 1Ds, 2Ds, but we didn't had capability to create 3D elements. Now we supported the 3D element creation within the create tool. So the next one related to smooth tool is we enhanced the algorithm to correct the mesh flow and the general element quality. You could see in the down below image wherein number of failures are less and the mesh flow is much better than compared to legacy version. So moving on to the solid meshing updates. In the Tetra, we supported the element selection. User need to take care of the volume and closivity. They need to be. We don't add the pre-check for now. Once we run the mesh algorithm, then we get to know that whether it is open or not. But during the selection process, we don't check the whether it is closed volume or not. So also we now support, let's say you have the all card mesh. In such cases, we earlier used to create pyramid element. Those were steep elements. Sometimes customer won't prefer having the pyramid elements. So now we provide a option to split them internally and not to split those cards. Just create, make use of those end nodes and create all tetras so that it gives all tetra elements. The next one is like in legacy version we had trouble with whenever we had growth rate less than 1.3. Still in the core mesh used to grow more, and we used to get the larger size in the core. So with latest versions, we improved the capability to even not to allow growing whenever you have the closer growth rate close to 1. If you can see the left side, wherein after skin within core it was growing higher. Now if you see the right side image wherein all the elements are in the same size, so it gives a consistent size distribution within core also. So this is great enhancement with respect to Tetra. And the next one is we have all new hex mesh tool. So this is essentially covers the our general hex mesh panel, the solid mesh panel namely, and earlier we had the line drag, ends only, linear solid. All of those cases we support now. This tool is much more enhanced in terms of selection, and we added lot of 3D topology direct selection, which saves a lot of clicks and mouse movements. I'll show the demo for this going forward. So earlier also, like you would have noticed that we had only solid map and thin solid, and in case of solid map, user need to have the mappable solids to create hex pentamesh, and in case of thin solids, bulky parts were not possible. In all these categories were insufficient. In some cases, user need to do a manual hex meshing using drag approaches, wherein user would select any one of the surfaces or elements or faces. I will explain each one of them, what we have done. So by default, in the hex tool, we as soon as user selects valid elements, we post the micro dialog and normal handle, wherein if user wants to create hex mesh within the by dragging within normal or along the normal, and also if user wants to switch the direction to a custom vector direction, you could do that using the vector option we have provided. The next option is to flip the normal direction. User can click on this to drag in the opposite direction of the normals, and also align to the global XYZ or custom direction, all of these, or user can key in the value of XYZ to get the mesh. So this is the one. The next method in this tool is to in above example, if you could see that there are source meshes in the hollow cylinder, but cylinder construction lines are not continuous. They are flipped 90 degrees in the bend. In such cases, mappable solid fails in those regions. So now with these announcement, we have robust the midline creation algorithm, and user can select those solids to get the midline, and make use of these elements as a source, and then select the midline to get the mesh. The bottom example is like user could use either surfaces or lines to drag or create hex as a guide. And the next one is related to faces. We added these faces newly, topological faces we support, irrespective of whether those are 2D faces or 3D faces. So user can quickly select a combination of those faces and get the hex created. In also additional to above cases, we also support the node path. We don't have any restriction on number of node paths. We can select different length node paths to define and then create a mesh. So the last one is match case, wherein user could select faces and targets, so source faces and target faces, or source elements or target faces in this case, and optionally user could define the along. It's not no, only source is the mandatory, and the along and target both are optional. So addition to this, like we also supported the 3D elements showing in the graphical legend what we have. So user need to switch to the 3D tab. in order to see the quality failures, and in order to integrate, or the user can go in individual element uh, and right click and change the values, or the see the individual quality failures. So I will do a short demo here. So in this case, I would be doing the hex demo quickly. So if you see, this is our classic model, wherein um, in the classic we have to follow more than 12 steps, but in this case I would show in lesser steps and lesser mouse movement how we can achieve the hex meshing. So so whenever we see the such part, basically we figure it out the uh, common faces or the shared faces, wherein we could create a quick mesh on those faces. I'm creating a quick mesh here on the shared faces and just adjusting my density along the direction. Since I have the linked opposite edges, I can go with, I know that here 6 is required, and here I need a 4 number of seats, and then I could do that. And in this one also I need to do a 6 here, and rest all are fine. So what I have done is, like, on the shared faces, I have created a mesh, and then in the next step, on those source faces, I will utilize those source faces. Either I can select surfaces or faces. I will go with the face. So once we select, we post this micro dialog. But as soon as if user needs a guide selection, in the guide selection, we have various options: lines, surfaces, faces, or the elements. In this case, I have better option to select surfaces. I could select surfaces, or I could even go with the lines and do a quick mesh here. So once I do this, I could again go back to my step 2 here in this case, or step 1. Yeah, that's fine. So so once I have this, I can just do a visualization change here. I could go here and select my source face, and then in the target, I could select these 3 faces where I wanted to match these two. And in the guide, I would need to select the surfaces. So I can select these surfaces here, and then I could exclude this one. Okay, now I have excluded, and then I have this in the target, and then I can mesh it. Once I have this mesh, I could just make use. You would have noticed already that in older process, every step we had to extract the faces and then make use of those 2D faces. But with enhanced selections and the uh, algorithm, we now provide direct 3D face selection without much hassle. So in the source, I could again select these 2 faces here, and in the guides, I will make use of node path here because there is no connectivity here. So I can just select this node, and then I could make use of these. I can add multiple paths here. Here I have added first path. I will do for second as well. And once I add it, I will confirm it. Once I got these, so I can just create a mesh out of this. And also I can make use of other avenues here. So I can just create a mesh out of these 2D mesh, and then again go back to my previous. And now we support advanced in the guides also we support faces, so that you don't have to always repair or go back and extract the faces, 2D faces, come back. Those steps are eliminated, so you can easily select these faces and create a mesh. And then last part, you can select these faces, or you could create 2D mesh for other surface as well, like remaining surface. And then you can just come back here and then select this face, these three faces, and either you could drag it or you could define your thickness or the value here and then confirm it to get the mesh. So once all of these steps are done, so you could go and do a equivalence. Basically, we try and find out unequivalence nodes, and we create faces out of that to make sure everything is connected and equivalence. You could see now we have face with which shows all the nodes have been connected and the part has been finished. And on top of this, we also provide direct face selection. So user can select it and then flip the direction of his choice or and then drag by defining number of loads. This helps to get the more quick layers or the quick getting the hex layers. So yeah, please make use of this and give us the feedback. And this is really handy tool now. So yeah, with this I will hand over to Tim for the further presentation. Thank you all.
Thanks, Yashwant. Let me share my screen. And while that is sharing, Yashwant has mentioned very briefly morph volumes tangency. So there's been some updates here from a panel migration perspective for morph volumes. Again, as we're trying to migrate out of the context, out of the panels and into context, this is one of the last kind of big important pieces from a morph volumes perspective. We're now migrating, we've migrated into a context. So what does this look like? I've got a very quick video just to cover these use cases, just to show you what the different morph volume tangency options look like, how to step between them, and then how to bulk edit them, and then a bit of a live demo at the end. So in this case, we're just going to create a volume around, a morph volume around these parts. It's a very simplistic model, just for demonstration purposes and for clarity as well. So we've got a new edges context now. We've automatically got the tangency set up between these, so we're going to turn this off. We're then going to establish what is known as a fixed tangency on each of the corners. So there's a bit of a way you can click through and set these up on each corner individually. Obviously, this is just the manual method. We've got bulk editing methods that I'll show at the end of this video. But this is obviously just setting up fixed tangencies. Now, if you've never used a fixed tangency, it's quite a useful option. Very buried before, but a bit more update now. But effectively, the intention behind this is to keep the end of the morph volumes at the same, effectively the same vector as it was before. So you can see without the tangency, you've got quite a sharp step. With the tangency on, it tries to keep it consistent. Removing the tangencies is now just a straight click, very simple to turn on. Setting up continuous, again, you select what you want the tangency between, you click between them, it's set up. So in this case, if I adjust one side, we see that it carries that through to the other volume. If I select the other side, again, we see the same behavior as we saw before. We can then step into secondary to main, or main to secondary, whichever way you want to call it. Now, the reason might be a bit counterintuitive, where we are going to adjust the direction of those tangency arrows. The way the arrows point at the moment and have always pointed is they point from the secondary to the main, so the tangency kind of flows opposite to what was previously what you'd expect it to. But we are adjusting that hopefully for 2022.3. So these are now the bulk editing options. So I can select all of my edges. I can pick a new tangency, or I can select make continuous, free, and it kind of goes through and then changes these through. So very, very easy now to go through and update your tangencies and be able to visualize them in a more direct method from a morphing perspective. So if I step into this model, I'm going to effectively go through that same process. So we're going to set up a symmetric cool. So I've got a symmetry. I'm going to remove the volumes in the middle, because I'm not really interested in these 4 volumes here. I'll delete those. And then if I go into my volumes and we go to edges, we can see we've got continuous around, we've got a symmetry. So I can select all of these and set my tangency here to fixed to current. So that basically follows the direction it already is. And again, I can go fixed to current. Select these ones, do the same process. And then if I go to split, we're going to split this down the mid. We're going to keep the tangency on. If we go back to edges, we've got continuous. Ooh, I don't know why those have dropped back out. I'll have to raise a ticket on that. And then because we have symmetry on, we should be able to adjust this. It should try and keep those to the same edges as they were before. If I turn snapping off, it might make it a bit smoother. No, still trying to snap. There we go, it's a bit smoother. But we can see it's trying to keep those ends at the same vector as they were previously. So that's kind of the whole idea behind the edges context, is a quick and direct method to go and adjust your tangencies on your morphomes. And that's really all from me. Thank you very much.